Yes, students, oxidation state, okay, is one of the very important property. Okay, 13 group element, okay, have general configuration what NS2 NP1. So generally these elements elements can show number A plus 1 oxidation state, okay, if only NP one electron involved, that is not S electron. Okay, this is called lower oxidation state. Lower oxidation state. Getting? And number B, this is plus 3 oxidation state. It is in which case if NS plus NP, that is what? 2 plus 1 electron involved in bonding involved. Okay, this is called higher oxidation state. Higher oxidation state. Okay, lower members like boron and aluminium shows plus 3 state, okay, with more stability, okay, while moving down the group, okay, plus 3 oxidation state becomes more stable, okay, student. Actually what, this is one of the very important concept, give rise to very important term, okay, which is in its explanation. Okay, actually as we move down the group, nuclear attraction force increases due to increase in what, number of what, proton, okay, and D and F electrons causes, as we have discussed earlier, okay, causes poor and improper shielding effect. Hence 2 electron of NS subshell okay, are unable to participate in bonding. Hence only 1 electron of S, okay, involved in bonding. Okay, this inertness okay, of 2 electron of S subshell, sorry, okay, here write P. this inertness of two electron of S subshell towards reactivity, towards what? Reactivity is known as inert pair effect. Student, it is a very important term. Inert pair effect, like poor shielding effect. Inert pair effect is also one of the very important term. Actually, what happens in p block element? Valence shell consists two subshell S and P. S has 2 electron and P has 1 electron. Okay, for lower member, that is boron and aluminium, there is no introduction of 10 electrons in D subshell. Therefore, they do not shows poor and improper shielding effect. Okay, that means what? That means the valence shell electrons are ready to combine and to form bond. Thus, 2 electron plus 1 electron, these 3 electrons can involve in bonding. But moving down the group, that is after aluminium, gallium, indium and thallium. Now, the 10 electron will introduce in D subshell, 14 electron will introduce in F subshell, and we know that the D and F subshell have very poor penetration effect. Okay, and therefore these are unable to shield the nucleus. Are you getting? And thus what? The electrons present in S subshell. In S subshell, how many electrons? 2 electrons present in S subshell. They are unable to react or unable to form bond. That means these 2 electrons do not involve in any type of bonding. Thus, now only 1 electron remains, and this electron remains in only what? P subshell, to which it can form bond. Thus, the plus 1 oxidation state becomes more stable as compared to the plus 3 oxidation state. Okay. Therefore, there is a question, why do the lower oxidation state for higher member becomes more stable? So, you have to write the answer. This is due to inert pair effect.